You are warmly welcome to Gurugedara educational program. You are here with me with another interesting science lesson for grade 10. I hope you are doing well and staying safe at your home. So, I am ready to start the lesson. Are you ready? Before I start, let me revise the things that we have done in my previous lesson. We learnt work, energy and power, that is unit 18 in your textbook. There we learnt work done, energy, different types of energy, and we concentrated more on mechanical energy. We learnt two types of mechanical energy as potential energy and kinetic energy. At last, we did potential energy in detail. We will start the lesson from that point and proceed further. Let me tell you the things we are going to do today. We will define kinetic energy, provide expressions for kinetic energy and list the instances where potential and kinetic energy is used in day-to-day life. We learn power as rate of doing work, and at last we do some calculations related to above concepts. Now, I am going to ask a question from you. Would you like to watch a video? Yes, let us watch video first and then we will continue the lesson. When you keep a ball in your hand like this, it has no kinetic energy, but as it falls, we see that it has kinetic energy. Kinetic energy is a form of energy possessed by a body due to its motion. Therefore, any object that moves has kinetic energy, such as car travelling in a road and plane flying in the sky. Even your body possesses kinetic energy when you walk and when you run. The faster a body moves, the greater its kinetic energy. So, when you run, you have more kinetic energy than when you walk. When body stops, no more kinetic energy in it. Let us see what happens when a ball is releasing from a certain height. It starts at rest and it gains certain speed when you let it go. In other words, it starts with zero kinetic energy and it gains some kinetic energy while travelling. Where did this kinetic energy come from? It comes from the potential energy stored in the ball due to its position. I think you learned something about kinetic energy from the video. So, let us define what the kinetic energy is. Kinetic energy is energy possessed by an object due to its motion. Kinetic energy depends on two factors, mass of the object as well as velocity of the object. Now, we are going to see how these two factors affect kinetic energy. Activity to show kinetic energy. Here you can see a trolley, it is a light trolley labeled as B and there is another object labeled as A. Project object A towards the trolley in order to collide with it with a certain velocity. So, what will happen? Light trolley will travel some distance, then measure the distance travelled by the trolley and then project object A with a higher velocity and again measure the distance travelled by the trolley. So, at last you get different objects with different masses instead of A and project them towards light trolley. Again measure the distance travelled by the trolley in each instance. Let us do this activity to learn more about it. Now, this is the object A I am going to use. This is the light trolley. Now, I am going to project this object towards light trolley. Look what will happen. So, it travelled some distance. Now, I use the same object and I increase the speed of it. So, that is how I am increasing the speed. I allow the object A to fall from here. So, this is like inclined plane. Let us see what happens. You saw it travelled longer distance than the previous time. Now, again, now I am going to change the mass of the object. So, this is a tennis ball and this is a leather ball. So, this is heavier than this one. So, first I project the tennis ball towards the trolley and you note the distance the light trolley travels. So, it travels a shorter distance like this. Now, I am going to use the leather ball to project towards the light trolley. Here I am applying the same velocity as I used to the rubber ball. So, now I am going to send the leather ball towards the trolley with the same velocity. You look what will happen. Here you observed light trolley travels a longer distance when I project with this leather ball than when I use the tennis ball. Now, let us see what the observations are. You saw trolley move some distance after the collision, and when the velocity of the object is higher, trolley moves a longer distance. In addition to that, when the mass of the object increases, distance travelled by the trolley also increased. So, you saw when I use the leather ball, distance travelled by the trolley increased. So, that we can conclude kinetic energy depends on these two factors, that is mass of the object and the velocity of the object. In other words, I can tell kinetic energy is directly proportional to the mass and the velocity of the object. So, now we are going to learn about an equation to do calculations related to kinetic energy. So, this is the equation Ek equals half mv squared. I used simple m for mass of the object, v for the velocity of the object, and I used Ek here to represent kinetic energy of the object. As I told you in my previous lesson, unit of work done is equal to the unit of energy. So, unit of kinetic energy is joule. If you want to measure large amount of energy, you have to use kilojoule. Now, let us do some calculations on kinetic energy, so that you will understand the concept of kinetic energy very well. So, try to do these calculations with me. First one, an object with a mass of 2 kg is travelling with a velocity of 5 meters per second. You are asked to calculate the kinetic energy. First of all, as I told you in my previous lesson, you have to write the equation. So, kinetic energy, I used Ek here to represent kinetic energy. Ek equals half mv squared. Then you have to apply values. Ek equals half, you know the mass of the object, that is 2 kg, and velocity v is 5. We applied the values now. Now, you have to solve this problem. Ek equals both these two cancels off, and square of 5 is 25. So, Ek equals 1 into 25, so that you get kinetic energy as 25 joule. Let us move on to the second problem. Mass of an object is 4 kilogram. If the kinetic energy of it is 32 joule, what would be the velocity of the object? This problem is little bit different from the sum we did before. Here you are not asked to calculate the kinetic energy, instead of that you are asked to calculate the velocity of the object. Try this problem to solve. Now let us do it. First you have to write the equation. Kinetic energy equals half mv squared, then apply values. So, you know kinetic energy, then you can put it there, then half mass again you know, so you write 4 there and into v squared. Then you will get 32 equals 2 into v squared. V squared equals 32 divided by 2 and you get 16. So, to get the velocity, you have to get the square root of 16, that is 4 meters per second. So, the velocity of the object is 4 meters per second. Let us do the third calculation. I think now you can do this calculation with me. Try it with me. Kinetic energy of an object with a mass of 200 gram is 10 joule. Find the velocity of the object. Here the mass is given in grams. Can you apply mass as grams? No. You have to use SI unit of mass, that is kilogram. So, in this particular sum you have to convert 200 gram into kilogram. Let us see how to do it. First, as usual, you have to write the equation, then apply values. Here you know the kinetic energy, it is 10 joule, and then you write half as it is, and this is the mass 200 gram divided by 1000. Now, you apply the value in kilogram into v squared. So, this is just like a simple algebraic equation. You can solve the problem now. So, 10 equals half into 0.2 into v squared, and 10 equals 0.1 into v squared. So, that v squared is 100 and you have to get the square root of 100 and the velocity is 10 meters per second. Now, I think you can solve any problem related to kinetic energy. So, with that knowledge, we will move into our next topic, that is energy transformation. Law of conservation of energy says that energy cannot be either destroyed nor created. Law of conservation of energy says that energy cannot be either created or destroyed. If I tell it in other words, energy can be neither created nor destroyed. So, it can only be transformed from one form to another. So, what is energy transformation? It is a process of changing energy from one form to another. That is what is meant by energy transformation. Let us look at different types of energy transformation. Now, children, think you are trying to light a bulb using a battery or dry cell in your home. So, there in dry cell or battery has chemical energy in it. When you light the bulb, that chemical energy is converted into electric energy. So, that is the energy transformation happening in that particular activity. If I talk further about it, using that electricity, bulb lights. So, that electricity or electric energy is again converting into the light energy. So, this is the energy transformation. Whenever you write energy transformation, you have to use an arrow like this to show the direction of energy transformation. Next one, electric energy into heat energy. This is also familiar to you. When you use iron to iron your clothes, you use the electricity at your home. There, electric energy is converted into heat energy. And think of hydropower plant and wind power plant where we used to generate electricity. Their kinetic energy is converted into electric energy. It is another instance of energy transformation. But we are concentrating on the fourth energy transformation in this lesson, that is potential energy into kinetic energy. Let us watch a video to learn more about fourth energy transformation, that is potential energy into kinetic energy. When a ball is released from a certain height, initially it has potential energy. When it is falling, potential energy is converted into kinetic energy. You know by now, the higher the ball, larger its potential energy. So, let us see another example for that. What you can see here? This looks like a catapult. An angry bird is placing there. When the rubber band is stretched, potential energy is stored in it. And as soon as it releases, potential energy is converted into kinetic energy. So, that kinetic energy can do a work on another object. Let us do some more examples related to energy transformations. Look at this picture. Apple is on a tree and that apple is falling from the tree. Here there are 3 points labeled in the diagram. At point A, apple has only potential energy, but at point B, apple has some velocity as it is falling. So, it has kinetic energy. In addition to that, apple is from a certain height from the ground. So, it has potential energy as well. So, at point B, apple has both potential energy as well as kinetic energy. Apple has highest kinetic energy at point C just before apple hits the ground. So, what happens when apple touches the ground? Kinetic energy and potential energy of apple both become 0 at once it hits the ground. So, let us do some more examples for energy transformations. Here first picture, in this first picture you can see a boy is riding a bicycle. He came riding the bicycle to the bottom of the mountain and now he is climbing up, riding the bicycle up to the mountain. Here at this level he has kinetic energy because he is riding the bicycle. He has a certain velocity. When he climbs up the mountain, kinetic energy gradually decreases and at the top of the mountain, all the kinetic energy he had is converted into potential energy. So, when he is riding down or coming down from the mountain, again the potential energy is converted into kinetic energy. So, this is how potential energy is converted into kinetic energy and kinetic energy is converted into potential energy. Look at this picture. This is very familiar to you. This is a swing. So, at this point it has highest potential energy. When you come here, you have maximum kinetic energy, and again at this point you have maximum potential energy and 0 kinetic energy. So, that is how potential energy is converted into kinetic energy and kinetic energy is again converted into potential energy. Look at this picture. A boy is trying to put a ball down. So, at this point it has potential energy. When he releases the ball, potential energy is converted into kinetic energy. And this is a pendulum. This is hanging from a rod. So, at this point it has maximum kinetic energy, and in these 2 points it has maximum potential energy and 0 kinetic energy, because in these 2 points this pendulum is not moving. Another example for energy transformation, here a weight is raised to a certain height and releasing. When it is here, it has potential energy due to the height, and when it is falling down, potential energy is converted into kinetic energy, so that this kinetic energy can do work on another object. You can see this peg is penetrating towards the ground. So, this example shows hitting a nail using a hammer. Here, when the hammer is raised, potential energy stored in it. When you release it down, potential energy is converted into kinetic energy, so that it can do a work on the nail. So, nail drives through the wood. This is bow and arrow. When you draw the bow, potential energy stored in it, and when you release the bow, potential energy is converted into kinetic energy, so that arrow travels away from the bow. I think energy transformations are clear to you now. Now, we move on to our next topic, that is the instances where potential and kinetic energy is used in our day-to-day life. Potential energy and kinetic energy is used in hydropower plants when generating electricity. This is the structure of hydropower plant. Here, dam is built across a river, and this is the reservoir. So, water is placed at a higher level. So, you know this water has high potential energy. When water is flowing, potential energy of water is converted into kinetic energy. So, kinetic energy of flowing water can rotate this turbine. So, this turbine is connected to the generator. Whenever the turbine rotates, generator is also rotating and electricity is produced, and so produced electricity is distributed throughout the country via these transmission lines. That is how electricity is produced. This is a closer view of the hydropower plant. Here this is the reservoir and water is flowing, and this is the turbine. Generator is connected to turbine, so that generator produces electricity and it is transmitted all over the country through these transmission lines. Children, now I will show you a picture of a dam. This is Victoria Dam. Let us see the energy transformation in a hydropower plant. Potential energy in stored water is converted into kinetic energy in flowing water, and then kinetic energy in turbine, and kinetic energy in turbine is converted into electric energy in generator. This is the second instance where potential energy and kinetic energy is used. Pile driver is a device used to drive piles into the ground. Here you can see a pile and pile driver. So, weight is used as pile driver, weight is raised, and when the weight reaches its highest point, it is released, so that it falls vertically down and hits the pile, hammering the pile into the ground. So, this pile driver is used in constructing tall buildings in order to support them. So, here again you can see the structure of pile driver and pile. In this picture you can see the pile is pointed. Why do you think so? It is because to penetrate the pile easily into the soil. Third instance where potential energy and kinetic energy is used is sledgehammer. I think you are familiar with this equipment. It is used to break stones and it is also used to cut firewood. In this first picture, you can see sledgehammer is used to break stones. When you raise the sledgehammer, it stores potential energy. So, when it is released, it breaks the stone into pieces. And when cutting wood, iron wedge is inserted into the wedge first and sledgehammer is raised or lifted and released onto the iron wedge, so that iron wedge penetrates through the wood, cutting it into pieces. So, let us see the energy transformation when cutting firewood. Potential energy when lifting the sledgehammer, it is converted into kinetic energy when releasing the sledgehammer, then kinetic energy transferred to the wedge, breaking it into pieces. So, that is the energy transformation when cutting firewood. Let us move on to our next topic, power. Power can be defined as rate of doing work or work done in unit time. Equation for power can be written like this: work done divided by time spent. Now, you already know equation for work done, that is force into displacement. So, we can write equation for power for like this: force into displacement divided by time spent. So, what is the unit of power? If work done is measured in joule and time measured in seconds, unit for power is joule per second, J S to the power minus 1. So, 1 joule per second equals to 1 watt. So, unit of power is watt. We can write the equation for power using symbols like this: P is for power, W is for work done and T is for time taken. So, this watt value is given in the electric appliances we use in our day-to-day activities at home. You can see here some bulbs are there and there are some electrical equipments. You can see the watt value by looking at these equipments. So, let us do some calculations related to power, so that you will understand the concept of power very well. First one, an object with a mass of 2 kg is lifted to a height of 5 meters from the ground. Time taken for that is 5 seconds. You are asked to calculate the rate of doing work. Here you are not asked to calculate the power, but you should understand rate of doing work is power. So, that you have to write the equation related to power. So, this is the equation: power equals work done divided by time spent. Now, you can apply values. Here in this particular sum, work done is not given and force is also not given, but instead you are given the mass of the object. Now, you know how to find the weight of the object when the mass is given. So, weight of the object equals mass into gravitational acceleration. Remember, we did this in my previous lesson. So, W equals 2 kg into 10 meters per square second. That is the value of gravitational acceleration. I hope you can remember this. Then you get a weight of the object as 20 Newton. Then force exerted to lift the object is 20 Newton. As I told you in my previous lesson, you should apply a force equal to its weight if you want to lift an object vertically upwards. So first force exerted to lift the object is 20 Newton and height lifted is given in the sum as 5 meters. So that you can calculate the work done, 20 into 5, so 100 joule. Time taken is also given in the sum as 5 seconds, so that you can calculate the power by dividing 100 joule by 5 seconds, so that you will get 20 watts for the power. Second sum, power output of a machine is 250 watts. Calculate the work done during a minute. So this is little bit different from the previous one. Let's do this. Power equals work done divided by time spent, so that you can apply values here. Power is 250 watts, that is work done in a second. So you are asked to calculate work done during a minute, that is work done during 60 seconds. Very easy. What you have to do? You have to multiply the power by time. Here you get the answer by multiplying 250 joules per second by 60 seconds. You will get the answer 15,000 joule. If you want, you can convert this into kilojoule. So what you have to do is you have to divide this by 1000, so that you will get 15 kilojoule. Now we have done some calculations related to power. Now I am going to do some revision exercises with you. Let's start. You also can try these revision exercises with me. First one, a child lifts a bag with a mass of 4 kg to a height of 1.5 meters. What is the work done? Gravitational acceleration, that is g, is given as 10 meters per square second. So first, as I told you earlier, you have to write the equation first. Work done equals force into displacement. Then force can be calculated by multiplying 4 kg into gravitational acceleration. So that is the weight of the object into displacement, that is 1.5 meters. So you will get 60 joule, and that is the work done. Let's do the second part of it. If a child took 3 seconds to do the work above, what is the rate of doing work? Again you are asked to calculate the power. Here the sum does not say it as power. So you should know that rate of doing work is power. As usual, you have to write the equation first. Power equals work done divided by time spent. So work done is 60 joule divided by 3 seconds. You will get 20 watts for power. Second sum. A mass of 200 gram is projected vertically upwards at a velocity of 20 meters per second. What is the kinetic energy of the object just as it is projected? Here you should write the equation for kinetic energy, Ek equals half mv squared. Then apply values, very easy. So mass is given in gram, so you have to convert it into SI unit, that is kilogram. So divide 200 by 1000. So v squared, that is square of 20. By simplifying this equation, you will get 40 joule for kinetic energy. Second part of it, how long will it take to reach the maximum height? To solve this problem, you need the knowledge related to acceleration, velocity and things like that. I hope you have done this lesson before. So acceleration equals final velocity minus initial velocity divided by time taken. You remember this equation? Let's apply values. So this is projecting vertically upwards. So final velocity is 0 and initial velocity is given in the sum as 20 meters per second. And since it is projecting vertically upwards, it is travelling against the gravity. So, it is not an acceleration. Velocity of the object reduces gradually. So, it is deceleration. Because of that, we put minus value here. So, acceleration is minus here, minus 10 meters per square second equals 0 minus 20 divided by time taken. So, you are asked to calculate the time taken to reach the maximum height. So, let us solve this problem, and this is again a simple algebraic equation. When you solve it, you will get 2 seconds for time taken to reach the maximum height. Let us do the third part of it. It asks the maximum height it would reach. So, when the object is moving vertically upwards, kinetic energy of this object is converted into potential energy. At the highest point, kinetic energy is equal to potential energy. So, that you can write equations for kinetic energy and potential energy, then apply values. Before that, these two m's are cancelling off, and then you will get equation half v squared equals gh. Now, you can apply values. Half into 20 into 20, you know g, that is gravitational acceleration, as 10, and h you write as it is. You are asked to calculate h. So, by simplifying this, you will get 20 meters for the height. So, that is the maximum height it would reach. The last part, what is the potential energy at the maximum height? So, you have to write the equation for potential energy as mgh and apply values like this: 200 divided by 1000 into 10 into 20 meters. So, you will get 40 joules for potential energy. Third calculation, answer the questions using following diagram. So, all the details are given in the diagram this time. You are asked to calculate the potential energy of the glass ball. So, you have to write the equation potential energy equals mgh. So, you know the mass of the glass ball as 5 kilogram, and gravitational acceleration is also given 10 meters per square second, and height is 1.2. So, that you can apply these values and you will get 60 joule for potential energy. Next part of the same problem, kinetic energy of the glass ball that reaches C is 40 joule, and you are asked to calculate the velocity of the object. In this instance, you have to write the equation for kinetic energy, that is half mv squared. So, then apply values. Kinetic energy is 40 joule, mass of the object is 5 kilogram, and you are asked to calculate velocity. So, we keep v as itself. Then by solving this problem, you will get 4 meters per second for velocity. Before I wind up the lesson, let me summarize the things I have done today. We did kinetic energy and we wrote expressions for kinetic energy, and we learnt instances where potential and kinetic energy is used in daily life. We learnt power as rate of doing work, and we did some calculations related to kinetic energy and power. With that, we came to the end of this lesson. So, you do some revision exercises related to this topic, and be aware of the instances where the principles we learned today is used in day-to-day life, and you be familiar with nature and gain more experiences during this vacation. So, children, I will stop here, hoping to see you again with another lesson in Gurugedara educational program. Stay safe, children. Have a nice day.